Howdy, we are the electrical engineering group and we are presenting the Butcher project video. My teammates are William Kluesner and Abhi Bulusu, and I'm Juan Lopez. Our group had several roles. I myself was a team manager and I ran quality checks on our content and all of our products, as well as tell everybody kind of what they need to do. Our team facilitator and product manager was William, and he made sure we met and organized meetings, as well as make sure everything was turned in on time. And finally, our research facilitator, Abhi, made sure all of our sources were correct and up to date. What is our project? Our project was choosing a field of engineering. Ours was electrical. And then we used that field to identify and solve problems we saw on several structures in the Galveston Bay area. Our electrical engineering and chemistry related to the sea. Well, electrical engineering is always used when building marine structures and technology. For example, microprocessors on boats and oil rigs, sensors and receptors used for sonar, and wires and generators to control the structures and power boats. How is chemistry related to the sea? Well, it's present in the process of corrosion, for example, and also it's also present in the process of galvanization, which is needed to prevent corrosion. One of the main challenges we faced was being able to come up with our main thesis. So what we did was follow our agreement, which was meet every day and make sure all of our content was of good quality. We also researched further on the field of engineering we chose and try to identify problems we've seen in other accidents, such as the Deepwater Horizon explosion. And then finally, we each came up with our own thesis and try to combine all of those into one main one. In the beginning, we had these theses, and then everybody made one, and then we finally combined it into this one main thesis, which was analyzing and explaining the effects of weathering on electrical devices caused by marine activities. And we believe that this damage could be prevented.
In our first finding, you can see an oil rig with barnacles on it, which is just outside of Pelican Island in Galveston County Bay. This is a corner view located at these coordinates located on screen. Our second finding was the battleship Texas, which was right next to the oil rig, also offshore of Pelican Island, located at these coordinates again. Our third finding was the remains of the SSS Selma, which was a concrete ship, and it was located at those coordinates, again, just off of Pelican Island shore. This is Pelican Island's bridge. It is the underside of the mechanical part of it, where you can see exposed wires and rust accumulating on the underside of it, located at these coordinates. And on our last finding, you can see the Pelican Island Bridge, again, this time from a different angle, where a boat recently hit and caused structural damage to the bridge, and a power line right near it, located at these coordinates. Our findings that are most related to our thesis, however, are going to be the oil rig, which has barnacles on it. The barnacles can cause damage when removed, especially if they're near cameras or sensors, wires, or anything electrical for that matter. Another important finding would be the Pelican Island Bridge underside, where you can see rust and exposed wires. These exposed wires, when rain on or weather hits them, you can experience surges in electrical power. And our final and arguably most important finding would have to be the damage to Pelican Island Bridge, as not only has the damage occurred on the bridge itself, it has also occurred to a power line right near it. And the power line could have easily knocked out power for days if taken out completely.
Howdy, my name is Abhi Bulusu, and I'm going to be talking about the sources we utilized in order to research our thesis. We utilized three main studies Our first one was from Wang and colleagues, 2023. Our second one was from Popkin, 2015. And our third was NERC, 2023. The 2023 study by Wang and colleagues studied the immediate harm that barnacles pose to maritime structures such as boats. Wang and colleagues eventually concluded that ultimately barnacles speed up the corrosion based on the dead material acquiring more bacteria. Moving to the picture in the center, we can see the degraded concrete, which is causing tidal wetlands to erode and be more damaged, as described by Popkin 2015. NERC 2023 discusses the severe impact that electrical systems pose to the marine environment, as displayed on the rightmost photo. Electronic devices can release harmful substances and chemicals into water bodies. These pollutants contribute to water pollution, affecting the marine organisms and ecosystems. How can our findings back our thesis? Well, as a whole, our thesis backs our statements in that we can observe the exposure to waves, moisture, and salt water contributes to corrosion, leading to damage in crucial systems. The photos displayed ultimately illustrate the broader point that common occurrences such as waves can cause easily preventable damage. As Juan mentioned in our thesis, common events like waves and rust can be prevented. Our research into barnacles causing corrosion on ship hulls reveals how the deterioration can affect fuel efficiency and impact the structural integrity. Additionally, studying concrete degradation in naval structures due to exposure to seawater and waves highlights the vulnerability of these installations. By understanding these processes, it is clear that proactive measures such as anti-fouling coatings and regular maintenance can effectively counteract these common occurrences and can preserve the durability of maritime assets. It's evidence that modern science as a whole can proactively solve the problem of degradation. So there are some scientific disciplines that can allow us to help us with this issue. Material science helps our understanding of the properties of materials and their behavior under different conditions. Material science can also be used to develop coatings, as I mentioned before, that can enhance concrete stability against factors like moisture, chemical exposure, and physical wear. Another science that can help deal with our problem presented in our thesis is corrosion science. Corrosion science deals with the design, construction, operation, and maintenance of vessels, ports, and offshore structures. It encompasses the naval architecture, ship design, and marine systems engineering. The use of corrosion-resistant alloys such as stainless steel and regular maintenance and inspections further contribute to minimizing the impact of corrosion. Another field that can help us prevent unnecessary environmental degradation is environmental science. Environmental science helps us examine the interactions between the environment and human-made structures and provides insights into how natural elements like waves, salt water, and weather conditions can contribute to degradation.
So engineering has to take into account cost, environmental impact, public safety, and effectiveness. So following this mentality, we brought your attention to a couple of solutions for these problems. One of them is just simply painting the iron that is exposed to the water. This can act as a barrier between the metal and the water with the oxygen inside of it. Another thing is galvanization, which is a process of applying a protective zinc coating to steel or iron to prevent rusting, which can be seen in this picture, which involves cleaning, rinsing, adding in the flux solution, which is usually zinc, and then cooling it and inspecting it. The process of rusting can be seen in this chemical equation, where the oxygen and the water plus the iron can equal rust on top of the iron, which can cause many problems when doing different things in electrical engineering. So if you look at the periodic table, we can see that the increasing reactivity, the iron is more reactive than the zinc, which is why galvanization is usually occurred. So the iron will more often than the zinc cause rust. Thank you for listening to our presentation. This has been the group on electrical engineering and chemistry. My name is William Kluesner, and my teammates are Juan Lopez and Abhi Bulusu.